Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Today we're going to be continuing this series on solving trigonometric functions using the product rule. And as you can see on the screen, we have the question, f of x is equal to cosine x multiplied by cotangent x. Now the first thing you have to do is to observe the function and see. In this particular function, we have two trigonometric subfunctions, cosine x and cotangent x multiplied by each other. And from the thumbnail, from the title, and from the information I just said a few seconds ago, then you're supposed to understand that we're going to be using something called the product rule, right? Product rule, generally, this is what the function looks like. It involves two subfunctions, in this case, small f of x, multiplied by another subfunction, in this case, g of x, to each other. And that is how you know when a function requires the use of the product rule, having two subfunctions or sometimes three subfunctions or more than three subfunctions multiplied by each other. For the purpose of this video, we have just two, f of x multiplied by g of x. And when we apply the product rule, we end up with something that looks like this. So the derivative of f of x multiplied by g of x, right, equals to the derivative of the first subfunction, and in this case, that's the derivative of small f of x multiplied by g of x plus the derivative of the second subfunction, g of x multiplied by f of x, right? When you have this information written down, then you can start solving. But before we start that, we have to look at our question and compare it to this. What is f of x in this question? What is g of x in this question? F of x in this question is cosine x. If you compare the position, f of x is the same thing as cosine x, and then you compare the second subfunction with the position, g of x is the same thing as cotangent x, right? So now that we have that information, all we have to do is substitute it into the product rule information. So now we have the derivative of the first subfunction, which is f of x, so that's cosine x, right, multiplied by g of x, which is just cotangent x, plus the derivative of the second subfunction, which is the derivative of cotangent x, right, multiplied by the first subfunction, which is cosine x. So now we have this, and we have to start doing the derivative. Now, if this is the first time on my YouTube channel, or the first video you're watching from my channel that involves trig, then you probably don't know this, but every single episode, what I do is I have this trig notes information written out first. That makes any sense? So like I have a page dedicated to trig notes. On the left side of the page, you have something called, or a group of information called trig expression, right? On the right, so what I mean by trig expression is how like trigonometric functions are expressed in relation to one another. So you have sine x is the same thing as 1 over cosecant x. You have cosecant x is going to be the opposite, which is cosecant x is 1 over sine x, right? You can see that sine x equals to 1 over cosecant x. Cosecant x is the same thing as 1 over sine x. If you come down, cosine x is the same thing as 1 over secant x. And secant x is the same thing as 1 over cosine x. And tan x is the same thing as 1 over cotangent x, or sine x over cosine x. Basically, all of this information on the left side of the page are called trig expression. On the top right corner of the page, you have what is called trig identities. And yeah, basically they are trig identities. They involve the squared of this same trig functions. And then everything that is written in red marker is trig derivative. So like derivative of sine x equals to cosine x, derivative of tangent x equals secant x. So they are all called trig derivatives. Okay, so that's it. So now we have the derivative of cosine x. What do we do from here? But before you go on, I wanted to mention, like, if this is the first time that you're watching my video, please pause this video right now and write all of this trig function, all of this trig expression, trig identities, trig derivative. Basically copy the entire trig notes into your note, because it's going to be very good for you to watch until the end of this series, as well as when I'm doing my when you're watching my videos on applying chain rule to trigonometric function, as well as applying power rule, quotient rule to trigonometric expression, not just this series. And it's also, a great note for you to keep for yourself, So now that we have that, what is the derivative of cosine x? The derivative of cosine x is the same thing as, we cut you negative sine x. So you have negative sine x here. Switch to black now. Multiplied by cotangent x, which is what is here. We're just going to drop that down, right? Plus, what is the derivative of cotangent x, right? Derivative of cotangent x is, derivative of cotangent x is negative cosecant square x. So you have negative cosecant square x, since you saw it on the previous page. Now that was multiplied by cosine here at the bottom, so we have cosine x. So when we write everything and rewrite everything, we have negative sine x, right? Cotangent x minus cosecant squared x cosine of x. So we have that written down. Now, if this is the first time again on my video, then you probably think, okay, this is good, this is the answer. Yes, actually, this is the answer. We already applied the product rule and this is our answer. But whenever you're dealing with trig, you want to find a way to make your work neater by basically doing something that you would call a cleanup, like a cleanup method. Basically, you simplifying a complicated answer into a less complicated answer by simplifying it, basically. So let's rewrite what we just had here. And what we just had here is negative sine x cotangent x minus, so we're just going to rewrite that on the next page and then simplify, right? So we have negative sine x cotangent x minus cosecant square x cosine x, right? So we have that, and yeah, let's start basically breaking the information down. So now, in order for us to simplify, I like to make my work, when it involves trig, I like to make whatever I have to be in form of sine and cosine, and that's what I'm going to advise us to do here. Let us make all of this information in terms of sine and cosine and see if we can cancel anything out or if we can factor anything out. So we have negative sine x, right? What is cotangent x? Let's go back to the first page. Cotangent x, we know that to be 1 over tan x, but we want our information to be in terms of sine or cosine or both. So we have cotangent x is the same thing as 1 over tan. What is 1 over tan also equal to? 1 over tan is the same thing as cosine x divided by sine x. If you're confused as to where I'm looking at, look at the bottom of the page where I'm like using a black marker. Look at the bottom of the page, cotangent x, where the information is in blue. So cotangent x cotangent x is the same thing as cosine over sine. So you have multiplied by cosine x over sine x, right? So minus, what is cosecant square x? Cosecant square x, what is that again? Well, we can call cosecant square x and we can just ignore the square and just find out what cosecant is. We have cosecant x is the same thing as what? 1 over sine x. So we have that and put that as 1 over sine x. But then the issue is this. You have a squared here. What are you going to do? When you have cosecant x is the same thing as 1 over sine x, and then you have, but now you have cosecant square x. What is it that going to be equal to be honest with you? It's just going to be cosecant square x is the same thing as 1 over sine squared x. So that's it. And then you have, obviously, multiplied by cosine x here. So now what can we do? Well, we have sine here in the numerator. We have sine here in the denominator. So we cancel them out, and our work can simply be negative cosine x, right? Now we have minus. Then we have now cosine x divided by sine squared x. But let's not forget that this information can be written as cosine x, right, over sine x. If you want to remove the fact that there is a squared over 1 multiplied by 1 over sine x. So this our answer can now be written as we can call this negative cosine of x minus cotangent x. What is 1 over sine x again? 1 over sine x, we know that to be cosecant x, just like we know cosine x over sine x is the same thing as cotangent x, so we can call this cosecant x. So therefore, our answer to this question is negative cosine x minus cotangent x cosecant x, or we can just do something else. We can just factor -1, and we'll just have this to be cosine x plus cotangent x cosecant x. So that is our answer. That is literally the answer, and that's it basically. But don't stop. Don't click off the video. I still have more information to tell you guys. So okay, so now that you have this, if you've been watching my videos previously, then you're gonna know that I always teach you guys the shortcut method. I would advise you that this is the best you can actually get, because this answer is good, right? If you are choosing this answer here, this is correct. It's not just as clean or as simplified as this answer at the bottom. So I would advise you to stick to the answer at the bottom, because it's cleaner, it's neater, it's more straight to the point, less confusing basically. But now the thing with the shortcut method here is I always teach you guys the shortcut method, which involves breaking down the functions the function into smaller bits and then differentiating that smaller bit. So in this case, we have cosine x, cotangent x. This can also be cosine x. What is cotangent x again? If you look at the first page, cotangent x is the same thing as cosine x, right, over sine x. So multiplied by cosine x over sine x, right? Well, what we have, we'll end up with cosine square x, right? We end up with that over sine x. Now, even though you might be thinking, well, we can work with this. Yeah, we can work with this, but it's not fun for us to be forced to differentiate this, right? So one thing I would advise you to do is, this is now more complicated than this question over here. So that's basically not the most fun thing to do, because if you want to differentiate this, you can basically you would have to do something called the quotient rule. Find what cosecant square x is going to look like to make our work less difficult, and then you're going to differentiate that. But it's not the best shortcut method. I would advise you to just stick to what we just did over here, and that should be it. But guess what? Let's play with it a little bit. Let's just see what happens, right? We have cosine square x here. Cosine square x, we know that to be, if we go back to the page where we have trig information, okay, so cosine square x, if we want to isolate this one here, then it's going to end up being 1 minus sine square x. So 1 minus sine square x. Okay, so let me erase this here and just have that. So 1 minus sine square x divided by sine x. So what we end up with here is going to be 1 over sine x, okay, minus sine x. So it's the same thing as saying cosecant x, okay, minus sine x. I want to see if we can play with this further. So now this is going to be what we'll be asked to differentiate. We can actually do the shortcut method with this. When we differentiate cosecant x, what would we get? When we differentiate cosecant x, we're going to get, if we go back to our first page, what's the derivative of cosecant x? The derivative of cosecant x here is negative cosecant x multiplied by cotangent x. Wow, we can actually do a shortcut method here. Negative cosecant x cotangent x. And what is the derivative of sine x, actually. What is the derivative of sine x? Well, the derivative of sine x is the same thing as cosine x. So our answer is actually negative cosecant x cotangent x minus cosine of x. This is absolutely beautiful. So when I said we couldn't really do a shortcut method, I take my words back. We can do a shortcut method and still get the same answer, because this information here and this information here are the same thing. The only thing is that with the shortcut method, I haven't factored out the negative one. So therefore, the shortcut method actually works. It works with almost everything. Even if the function is quite complicated, it still works. So I hope this video has been helpful to you. Make sure if this is the first video you are watching, you should watch the previous 9 videos. They're very, very helpful. It gives you an idea of what we've been doing, and it gives you a good understanding of what we've been doing. So you can see that to answer a question, we've gotten the answer in 3 different ways. We got the first answer in the complicated answer way when we applied the product rule, then we cleaned it up to get this one, and then when we tried the shortcut method, we got the cleaned up answer as well. So 3 different answers, 2 different methods, the shortcut method and the product rule method. I wish you guys all the very best. Make sure you take good care of yourself. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.